Imagine standing in the middle of Antarctica. There is nothing around you except white. No trees, no roads, no rivers, no exposed ground. Just a frozen surface stretching farther than you can see. Now imagine drilling straight down. 1,000 feet, half a mile, 1 mile, 2 miles. You might expect to eventually reach nothing more than frozen rock, but that is not what scientists have found. Beneath Antarctica's ice lies an entire hidden world. There are mountain ranges with sharp peaks and deep valleys. There are enormous canyons buried in complete darkness. There are rivers flowing where sunlight has never reached. There are hundreds of lakes trapped beneath the ice, including one so large that it rivals some of the Great Lakes on the surface. And in at least one of these buried lakes, scientists have discovered living organisms surviving without sunlight beneath hundreds of meters of ice. But perhaps the strangest discovery is something even older. Researchers have found enormous landscapes beneath East Antarctica that appear to have been shaped by rivers before the continent became the frozen world we know today. Some of this terrain may have remained hidden and almost untouched for tens of millions of years. It means that beneath the blank white surface of Antarctica is another Antarctica, a continent we cannot see. And the deeper scientists look, the stranger it becomes. Today, we are going to descend through the Antarctic ice sheet and discover what is really hiding beneath more than 2 miles of ice. And at the end, we will see why this buried landscape may be one of the keys to understanding what happens to Antarctica in the future. Our journey begins at the surface. From above, Antarctica looks deceptively simple. Satellite photographs show an enormous white mass covering the bottom of the planet. The surface rises gradually toward the interior, forming a frozen plateau that appears almost smooth. For centuries, that was essentially all humans could see. Explorers could cross the ice, scientists could drill into it, aircraft could fly above it, but the actual continent underneath remained invisible, and that created a strange problem. Imagine covering the entire United States with a blanket several kilometers thick and then trying to draw a map of every mountain, valley, and river beneath that blanket without removing it. That is essentially what scientists have been trying to do in Antarctica. The breakthrough came from radar. Research aircraft began flying long lines across the continent while transmitting radio waves downward through the ice. Ice is surprisingly transparent to certain radar frequencies. The signal can travel through thousands of meters of frozen material, strike the rock or water underneath, and bounce back toward the aircraft. By measuring how long that signal takes to return, scientists can estimate the thickness of the ice and the shape of the ground below. One flight gives you a line. Thousands of flights begin to reveal a continent. Over decades, researchers combined radar measurements with satellite observations, gravity measurements, seismic data, and information about how the ice itself moves. The result became increasingly detailed maps of the world beneath Antarctica. And in 2025, scientists released BedMap 3, the most detailed continent-wide map of Antarctic ice thickness, and the landscape below it yet assembled. The numbers alone reveal how difficult this world is to imagine. Antarctica contains roughly 27 million cubic kilometers of ice. The average thickness is close to 2 kilometers. But in the deepest known location, the ice is approximately 4,757 meters thick. That is nearly 3 miles of solid ice. Now remove all of that ice in your imagination. What appears underneath is not a smooth continent. It is a violent landscape. There are broad plains, deep basins, long valleys, cliffs, mountain chains, and enormous sections of the bed lie below present-day sea level. In some regions, the land plunges kilometers beneath the surface of the ocean. One of the most dramatic examples lies beneath Denman Glacier in East Antarctica. Researchers mapping the area revealed an enormous trough extending deep into the continent. Parts of this buried landscape descend roughly 3.5 kilometers below sea level. Standing at the bottom, if the ice and water somehow disappeared, you would be surrounded by a geological depression on a scale almost impossible to appreciate from the surface. And yet, from above, there is practically no indication that it exists. There is only ice. But canyons are only the beginning. Travel toward the center of East Antarctica and you encounter something even more extraordinary. A mountain range that humanity discovered without ever seeing it. Deep beneath the ice are the Gamburtsev subglacial mountains. On the surface above them, there is no dramatic chain of exposed peaks. There is only the enormous frozen plateau of East Antarctica. But radar revealed that underneath the ice are rugged mountains, valleys, and sharp alpine terrain. Some buried peaks rise more than 2,500 meters above sea level. The landscape has been compared to major alpine mountain systems, and that immediately created a mystery. Mountains exposed to glaciers are usually attacked by them. Moving ice can grind rock away, widen valleys, and reshape entire ranges. Given enough time, glaciers are capable of transforming sharp mountain terrain into something much more eroded. But the Gamburtsev Mountains are buried beneath an ice sheet whose history extends back tens of millions of years. So why are parts of the landscape still so rugged? The answer appears to lie in the strange relationship between the ice and the land. Not all Antarctic ice behaves in the same way at its base. In some places, geothermal heat from inside Earth, friction and pressure allow liquid water to exist where the ice meets the ground. The bottom of the glacier can move, it can slide, it can erode. But in other extremely cold regions, the ice can remain frozen to the bedrock. Instead of acting like giant sandpaper grinding across the mountains, the ice becomes more like a protective lid. It covers the landscape and preserves it. And this is where Antarctica begins to behave like a geological time capsule. Because the buried mountains are not the only ancient terrain scientists have found. In East Antarctica, radar observations have revealed enormous landscapes that do not appear to have been created by the modern ice sheet at all. They were shaped by something that seems completely out of place beneath the coldest continent on Earth: rivers. Long before Antarctica became completely buried beneath ice, its climate was dramatically different. Go far enough back in geological time, and Antarctica was part of the supercontinent Gondwana. It was connected to other land masses, including Australia. The continent experienced climates far warmer than anything found there today. Water moved across exposed ground. Rivers carved valleys. Sediment traveled toward the coast. Landscapes developed beneath open skies. Then the planet changed. Around 34 million years ago, a major Antarctic ice sheet began to develop. The continent was gradually transformed. Rivers disappeared beneath ice. Valleys were buried. Mountains vanished from view. Eventually, landscapes that had once been exposed to rain, wind, and flowing water were sealed beneath kilometers of ice. For a long time, scientists assumed that the enormous weight and movement of the ice must have destroyed much of that ancient surface. But radar began finding something unexpected. In 2023, researchers described a vast ancient river landscape preserved beneath central East Antarctica. The terrain extended across an enormous region and contained upland blocks separated by deep valleys. Its shape suggested that rivers had helped form the original landscape before the continental ice sheet covered it. Then came an even larger discovery. In 2025, researchers reported remarkably flat ancient surfaces beneath a roughly 3,500-kilometer stretch of East Antarctica's margin. Some of these surfaces may have begun forming more than 80 million years ago, when Antarctica and Australia were still connected. They appear to have been shaped in part by large river systems long before the continent was swallowed by ice. Think about what that means. There are places beneath Antarctica where the ground may preserve elements of a world that existed before humans, before our species, and long before the modern polar environment existed. A landscape can sit in darkness beneath kilometers of ice, while continents move and entire groups of animals appear and disappear from the planet above. But if this ancient land has been trapped beneath ice for so long, another question appears. Where does all the liquid water under Antarctica come from today? The answer seems impossible at first. At the surface, temperatures can fall far below freezing. Yet travel several kilometers downward and conditions change. The enormous ice sheet acts as insulation. Heat escaping slowly from Earth's interior warms the rock from below. Pressure from the weight of the ice changes the conditions at which ice can melt, and where the base is warm enough, small amounts of ice turn into liquid water. That water does not necessarily remain in one place. It can collect, it can flow through channels, it can move between reservoirs. Beneath what appears from space to be a frozen desert is an enormous hidden hydrological system. Scientists have identified more than 600 Antarctic subglacial lakes. Some are relatively small, others are enormous. And the most famous is Lake Vostok. If you stood on the Antarctic surface above Lake Vostok, you would see almost nothing unusual. You would be standing on a vast plain of ice, but several kilometers beneath your feet would be liquid water. Lake Vostok is more than 250 kilometers long. In places, it is around 80 kilometers wide. Its water can exceed 500 meters in depth. Above it lies roughly 4 kilometers of ice. The scale is difficult to visualize. Imagine an enormous lake roughly comparable in surface area to one of North America's Great Lakes. Now place a ceiling of ice several kilometers thick over the entire thing. No sunlight reaches the water. There are no waves visible from the surface. No shoreline can be photographed. A person standing directly above it would have no idea that an enormous body of liquid water existed below. For scientists, Lake Vostok presented one of Antarctica's greatest questions. Could anything live there? The idea seems absurd. Life at Earth's surface is overwhelmingly powered by sunlight. Plants capture solar energy. Animals eat plants or other animals. Food chains ultimately connect back to the sun. But beneath the Antarctic ice, there are environments where sunlight has been absent for extremely long periods. If life exists there, it needs another strategy. And scientists eventually obtained an answer from another hidden lake. Subglacial Lake Whillans in West Antarctica lies beneath roughly 800 meters of ice. Unlike Lake Vostok, researchers managed to directly access its water and sediments using carefully controlled drilling techniques. What they found changed the way scientists thought about the world beneath Antarctica. The lake contained active microorganisms. They were not surviving because sunlight somehow reached through the ice. It did not. Instead, microbial communities could obtain energy from chemical reactions involving materials in the water, rocks, and sediments. In other words, this buried world contained an ecosystem powered by chemistry. There are organisms living in permanent darkness beneath Antarctic ice, not giant creatures, not prehistoric animals trapped in a secret ocean, but something scientifically more important. Proof that life can persist in an environment that, from the surface, appears almost completely disconnected from the biological world above. And suddenly the darkness beneath Antarctica stopped looking empty. It became an ecosystem. But the water itself held another surprise. For decades, scientists often imagined subglacial lakes as isolated containers. Water collects beneath the ice. The lake remains in place. Nothing dramatic happens. Satellite observations showed that this picture was wrong. Scientists discovered that some Antarctic subglacial lakes fill and drain. Water can move from one region to another beneath the ice. When a buried lake gains water, the ice surface kilometers above it can rise slightly. When the lake drains, that same surface can sink. Satellites can detect these subtle movements. That allows scientists to track water they cannot directly see. It revealed something extraordinary. Antarctica has plumbing. Hidden rivers and drainage systems connect parts of the continent beneath the ice sheet. Water moves through channels. Lakes exchange water. Some reservoirs gradually fill and then release enormous quantities into other parts of the system. And this matters because water changes the way ice moves. Think of pushing a heavy object across dry concrete. Now, put water underneath it. The behavior changes. Something similar can happen beneath glaciers. Water at the base can reduce friction in certain locations and affect how rapidly enormous masses of ice travel toward the ocean. This means that a lake buried kilometers below the surface can influence the movement of ice high above it. And now the hidden landscape becomes much more than a scientific curiosity. Mountains steer ice. Valleys concentrate its flow. Water lubricates parts of the bed. Ridges can slow retreat. Deep basins can create pathways that allow changes at the coast to travel farther inland. The shape of Antarctica underneath the ice helps control the behavior of Antarctica above the ice. That realization has changed the way scientists think about the continent. For decades, some of the most important measurements seem to be on the surface. How quickly is a glacier moving? How much ice is being lost? How warm is the surrounding ocean? All of those questions remain critical. But now there is another one. What is the glacier sitting on? Imagine two enormous blocks of ice that look identical from above. One rests on high, rough bedrock with ridges capable of slowing its movement. The other rests in a deep valley that slopes far inland below sea level. Their futures can be completely different, and this is why scientists have spent decades trying to map something no human being may ever directly see. The landscape beneath Antarctica can determine where ice is stable and where it may be vulnerable. In some places near the coast, deep troughs can provide routes through which relatively warm ocean water approaches the underside of floating or grounded ice. If retreat begins along certain bed shapes, the geometry underneath can make it easier for that retreat to continue inland. In other regions, buried ridges act more like breaks. So the mountains, valleys, and canyons beneath Antarctica are not simply fossils of the past. They are part of the machinery controlling the continent today, and this leads to the strangest part of our journey. For most of human history, Antarctica seemed like a place with almost nothing beneath its surface except more ice. Now we know the opposite is true. Remove the ice, and a completely different continent appears. There are mountain ranges humans have never climbed, valleys no human being has ever walked through, canyons that exist in permanent darkness, ancient plains shaped when Antarctica belonged to a much warmer world, more than 600 known subglacial lakes, water moving through hidden drainage networks, and microbial ecosystems surviving without sunlight beneath the ice. Somewhere below the blank white surface are rocks that may preserve information about climates tens of millions of years old. Sediments beneath hidden lakes may contain records of how the Antarctic ice sheet expanded and retreated in the distant past. And that history matters because the ice above these landscapes contains an enormous quantity of frozen water. East Antarctica alone contains enough ice that, if it were ever completely lost, it would represent roughly 52 meters of potential global sea level rise. That is not a prediction that East Antarctica is about to disappear. It is a measure of scale. It tells us why understanding the ground underneath the ice is so important. We are trying to predict the behavior of one of the largest ice masses on Earth, while large portions of the terrain controlling that ice remain difficult to observe directly. And despite decades of exploration, Antarctica continues to surprise us. In 2025, BedMap 3 added tens of millions of measurements to our picture of the continent and filled major gaps in regions scientists had struggled to map. Yet even the most detailed map is still built from lines of measurements, remote sensing, and physical models. There remain places where no drill has ever reached the rock. There are buried valleys from which no sediment sample has ever been recovered. There are lakes that have never been directly explored. There may be landscapes whose detailed shapes have still not been mapped. So if you could somehow descend through 2 miles of Antarctic ice, you would not simply be traveling downward, you would be traveling backward. Past snow that fell thousands of years ago, past ancient layers of compressed ice, past a frozen archive of Earth's atmosphere, until eventually you would reach another world, a world of mountains, rivers, lakes, and ancient landscapes sealed away beneath the coldest continent on the planet. And perhaps that is the real mystery of Antarctica. The most interesting part of the continent may not be the ice we can see. It may be everything the ice has been hiding. If you enjoy discovering the hidden forces and forgotten worlds beneath things that seem familiar, subscribe to the channel. Because there are still places on this planet that we have mapped from space more easily than we have explored beneath our own feet. And Antarctica is only the beginning.